A whirlpool is one of those things that's just hypnotic, right? So powerful. But have you ever stopped to think what's really going on under that spinning surface? Well, we're about to dive in and find out.
So yeah, we're basically going to peel back the layers of this thing, this incredible fluid phenomenon, to really get a look at the wild, chaotic world that's hidden right under our noses.
Okay, so let's start with what we can see, the spinning surface. But trust me, the real story is what's happening underneath.
You look at that hypnotic spiral and it might seem almost peaceful, but it's actually a sign of some seriously intense forces clashing. We're talking about a world of turbulence, shifting pressures, a whole hidden structure just beneath the waves. So that begs the question, right? How does a whirlpool even form in the first place? Well, it turns out you just need a few basic ingredients to get one started.
It could be something huge like massive ocean tides getting squeezed through a narrow channel, or, it could be as simple as water going down your bathtub drain. The principle is exactly the same. You just need some kind of disturbance or converging currents to give the water that first little spin. And that tiny rotation, that's the seed for the whole thing.
And this is where the magic really happens. It's a core principle in physics called the conservation of angular momentum. This is the engine that takes that gentle initial spin and ramps it up into a super powerful, high-speed vortex. The classic example here, and it's a great one, is an ice skater. You've seen this, right? When their arms are out, they spin kind of slow. But the second they pull their arms in tight, bam, they speed up like crazy. That's exactly what's happening with the water. As it gets pulled closer to the center of the vortex, it spins faster and faster.
Okay, so now let's imagine we're actually going inside that V-shaped funnel, because it's not just a hole in the water. No way. It's pretty much a battleground between some major forces. First up, you've got centrifugal force. As the water spins faster and faster, this force is trying to fling it outward, away from the center. This is what starts creating that dip, that depression in the water's surface.
But at the exact same time, you've got good old gravity, and it's pulling all of that water straight down. So it's constantly fighting against that outward push, and that's what creates the depth of the funnel.
So what you get is this constant tug-of-war, right? Centrifugal force pushing out, gravity pulling down. And the result of that battle is the V shape, that iconic vortex funnel we all recognize.
And there's another piece to this puzzle: pressure. Thanks to something called Bernoulli's principle, where the water is spinning the fastest, right at the core, the pressure drops like a rock. It creates this zone of super low pressure, almost like a vacuum, that sucks everything inward and actually makes the whole whirlpool structure even stronger.
All right, now let's get into the really cool stuff, the hidden world within the whirlpool. Because the flow of water in there is anything but simple. It's actually a super complex layered system.
Think of it in layers. On the very outside, you have these broad, slow-moving arcs of water. Then as you move in, the layers get tighter and start spinning way faster in a helical pattern. At the very center is the vortex core, which is just pure, intense, chaotic motion. And that little calm spot you sometimes see right in the middle, that's the vortex eye. Total calm in the center of the storm.
So get this, the water isn't just spinning around in a flat circle. It's actually spiraling downwards, like a corkscrew. And because you have these different layers moving at different speeds, you get a ton of friction between them, what we call shear forces.
And what does all that friction create? It creates eddies. You can basically think of eddies as mini whirlpools inside the big whirlpool. They're these little pockets of chaotic, swirling water, and they're the reason the inside of a vortex is so incredibly turbulent and unpredictable.
Okay, so we've covered the physics. Now let's bring this back to the real world and look at some actual whirlpools, from the tiny ones we see every day to the absolutely massive ones.
This is a great comparison. On one hand, you have the water going down your sink drain. On the other, you have the famous Naruto whirlpools in Japan. I mean, the scale is just mind-bogglingly different, but the physics, the fundamental principles at play, they're exactly the same. The only difference is the Naruto whirlpools are caused by insane tidal flows and can spin at over 30 kilometers an hour, fast enough to be a real danger to boats.
And just to give you a sense of scale, those whirlpools in Japan can get up to 20 meters across. I mean, that's huge. You can see why you wouldn't want to get your boat anywhere near one of those.
Okay, so for our last section, let's zoom out. Because this spiral shape, it's not just a water thing, it's a universal pattern. You can find it literally everywhere.
Seriously,
Think about it. Tornadoes, hurricanes, even giant storms on other planets like Jupiter's Great Red Spot, they're all vortices. And if you zoom out even further, what about spiral galaxies? It's the same fundamental shape, just on an unimaginable scale.
And that's not a coincidence. It's what happens in physics when rotational forces take over. It's a self-organizing solution. So whether the fluid is air or water or even a galaxy made of billions of stars, this elegant spiral shape is just one of nature's go-to patterns for handling all that motion.
It's just amazing to think about. Peering inside a whirlpool is like getting a glimpse of the invisible architecture of how things move. So really, the next time you see water going down the drain, just stop for a second. You're not just watching water drain, you're watching a tiny demonstration of the same laws that shape oceans, planets, and entire galaxies. You're witnessing the invisible architecture of the universe, made visible.